Good morning, class. I'm going to be going through the practice assignment number 1, which was on PM Students. It's the online assignment. I've gotten this from about half of you guys, so just make sure you guys submit this by the end of the day on Friday if you want to receive full completion points credit. Okay, so first question on Performance Matters says determine the discriminant of this following quadratic equation. If you remember what the discriminant tells us, it tells us how many x-intercepts our quadratic will have. Remember, our options are the quadratic will have 2 x-intercepts, so it'll cross the x-axis twice, something like that. It could potentially have 1 x-intercept that comes down, kisses the x-axis, or it could also potentially have no x-intercepts, as in it doesn't even touch the x-axis. All right, so a little fact about this is when you are calculating the discriminant, if your discriminant is greater than 0, right, you will have 2 real solutions, right? You'll have 2 x-intercepts. If your discriminant is 0, you will have 1 real solution. So that's that case where it comes down and it touches the x-axis. And if your discriminant is less than 0, as in a negative number, you will have 0 real solutions, which looks like this right here. It doesn't even touch the x-axis. Okay, so when going through and doing this, we want to make sure that we have our quadratic equation in standard form. So this right here, x squared plus 11x equals 12, is currently not in standard form. Standard form means everything is on the exact same side. So I'm going to bring this 12 over to the left. Since it's a positive 12, I am going to subtract it. I get x squared plus 11x minus 12 equals 0. So before I do any work, I need all 3 of my terms to be on the left-hand side of that equal sign. All right, now that I have all terms in standard form, I can now do that discriminant formula. That formula for calculating the discriminant is b squared minus 4ac. That should look familiar because that is the part that is under the square root sign in the quadratic formula. All right, so I want to label a, b, and c and plug it into my formula and then figure out what my solution is. So a in this case is 1. Remember, a is always the number attached to x squared. B is 11. It's the number attached to the x term. And c is a negative 12. All right, when I'm plugging this in, I'm just going to make sure I put my a, b, and c in parentheses where I have a b, an a, and a c up here. So I have 11 squared minus 4 times 1 times negative 12. All right, I can use my calculator for this. It doesn't have to be a fancy calculator. Just make sure you're typing in those parentheses. We have 11 squared minus 4 times 1 times negative 12, and that gives me a positive 169. So the answer to this question, my discriminant is 169, which means you have 2 x-intercepts, or 2 real solutions, right? Remember, those are synonyms. That's it. First question done. All right, second question on your Performance Matters assignment number 1. It gives you a quadratic equation, also not in standard form, so we want to, address that. But it says, is this going to be a rational or irrational solution? So just quick little definition here. A rational number is a number such as like 2/3 or 1.5. It's a fancy way of saying a fraction or a nice clean whole number or decimal. The textbook definition of a rational number is a number that you can write as a fraction, or a number that terminates, the decimal terminates as in it stops. It doesn't have numbers keep going on forever. And it also, it could be a repeating decimal. So like 0.333333 is 1/3. That is a rational number. An irrational number is just the opposite. Irrational numbers are something like pi for the number e. I know e is a letter, but e is actually 2.71, blah, 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 blah. It keeps going on forever. So an irrational number is a number that doesn't terminate, as in the numbers just keep going on forever, 3.141592. I remember pi keeps going on forever. And it also does not repeat. All right, so when I'm doing a problem like this, I want to calculate my discriminant, and I want to see if I can take the square root of that discriminant. If you can take the square root of that discriminant and get a nice number, then it's a rational solution. If you take the square root of the discriminant and get a not so nice number, then it's an irrational solution. All right, so first thing I want to do is I'm going to take my quadratic equation, 2x squared minus 14 equals a negative x, and I'm going to put it into standard form. So I'm going to bring this term over to the left, right? And I get 2x squared plus x minus 14 equals 0. Right? Always get in the habit of writing the x squared term, then the x term, and then the constant. All right, so now I'm going to do that discriminant formula. Remember, it is b squared minus 4ac. A in this case is 2, b in this case is 1, c in this case is a negative 14. I'm going to plug all these numbers into my formula with parentheses, right? I get 1 squared minus 4 times 2 times a negative 14. Pull out my calculator again if I don't drop it. And we're going to type this in. We get 1 squared minus 4 times 2 times a negative 14. And we get a 113. We get a 113. All right, so my discriminant is 113. Okay, so now what I want to check to see if it's a rational or an irrational solution is, can I take the square root of 113? And if I can, what do I get? Is it a nice number or is it an ugly solution? All right, square root of 113, and I get this pretty ugly number, 10.63014581. So you have to ask yourself this question: does this decimal terminate, as in does it stop? It doesn't look like it stops. It looks like it's going to keep going to the right. Our calculator just isn't large enough for it to keep going, so it just actually stops after that one digit, but it doesn't technically stop. It keeps going. And then, is this decimal repeating? Do you have like 0.33333, or is it going like 1, 2, 1, 2, 1, 2? It doesn't look like it has any pattern. Therefore, it is an irrational number. It doesn't repeat and it doesn't terminate. All right, so the answer here is it is an irrational solution. Irrational solution. All right, moving on. Moving on to question number 3. Question 3 and 4, we are using the quadratic formula to find our x-intercepts. All right, so first question, are we in standard form? Ax squared, bxc, all on the left-hand side, equal to 0, so I'm good. All right, first step, label A is 5. B is a negative 1. C is a negative 4. All right, remember the quadratic formula is that the biggest formula you need to have known going into next year. Remember, it's x equals the opposite of b plus or minus the square root b squared minus 4ac. Remember, that's that discriminant part, all over 2a. All right, first step, I'm going to take my A, B, and C, and I'm going to plug everything in that I can. Those notes that you guys were given for this week, they already had those parentheses in there for you, so I'm going to kind of model that. I get x equals, B is a negative 1. I can go back and clean this up in a little bit. Don't forget your plus or minus, square root. We have B squared minus 4 times A times C. Make sure that square root goes over the entire thing. And that is all over 2A, which is 5. Okay, so the first thing that I always like to simplify is, first off, I like to simplify this. I technically do this before I even write this. The way I read this is the opposite of B. So I technically would have just wrote a 1 here, because B is a negative 1. This is going to eventually turn into a positive 1. So that's just kind of your, whatever method you like to work with best. So x equals, I know that's going to turn into a positive 1. Don't forget your plus or minus. I'm going to type in everything under my square root to figure out what my discriminant is. It tells me how many solutions I will have. So negative 1 squared minus 4 times 5 times a negative 4, which is an 81. So 81 goes right here, and then hopefully you guys agree with me, 2 times 5 is 10. All right, I kind of do like a little cheater here because 81 you can take the square root of and get a nice number. If you take the square root of 81, we get 9. All right, so I can furthermore write this as x equals 1 plus or minus 9 over 10. Everything is now kind of done mathematically. I now can just break this into my two problems. All right, when I break this into my two problems, I get 1 plus 9 over 10, right? 1 plus 9 over 10, and I get 1 minus 9 over 10. And then I just have to do a little bit of math here to figure out what my two solutions are. 1 plus 9 is 10. 10 divided by 10 is 1. 1 minus 9 is a negative 8. Negative 8 over 10, and I can reduce this. Right? I can divide this by 2, and I can divide this by 2, and I get a negative 4 over 5. Those are my two x-intercepts. Those are my two solutions. Make sure you circle them, 1 and negative 4/5. Guys, make sure you show all of your work. If you choose not to show your work on the computer and you want to instead do it on a separate sheet of paper like I am, take a picture of it and email it to me. That's how you're going to get full credit, especially come assessment time. All right, last question, number 4. It says use the quadratic formula. Sorry, let me move my coffee up here. Very, very similar question. It's just going to be a little bit sloppier of an answer. All right, so good news, I'm already in standard form. Let's go through and label A, B, and C. A is 1, B is 12, and C is 10. All right, I'm already in standard form, so I can jump right into my quadratic formula. So you can either look at the top of your page that you're doing right now, or I'm just going to rewrite it again right here. X equals the opposite of B plus or minus the square root B squared minus 4AC all over 2A. All right, let's go through. Plug all my good values in. We get X equals B is 12 plus or minus the square root 12 squared minus 4 times 1 times 10, and that is all over 2 times 1. All right, two things I always like to clean up. I like to clean up this first term, right? So I know that this is going to be x equals a negative 12, right? Negative 1 times 12 is just a negative 12, plus or minus. Let's figure out what our discriminant is. Hopefully it is as clean as it was up here in 81. I kind of doubt it. Let's check it out. All right, so we have 12 squared minus 4 times 1 times 10, and we get a 104. So not as nice. 104, and that is all over 2 times 1 is 2. Okay, so the reason why it's not as nice, if you go through and take the square root of 104, oops, don't need that parenthesis, we get an irrational number, right? It wasn't like 9, like the previous example. It's 10.19, and I don't want to write that, right? So we're going to go through and solve this two different ways. I'm going to give you an exact solution. We're going to do a factor tree for 104, if you remember that. And then we're going to also give approximate solutions. So let's go through and let's do the exact solution first. Those of you who came into the Google Meet yesterday, we did this example together, so this should be kind of review. I'm going to take my discriminant, 104, and I'll come over here, and I am going to break it down, if you remember how to do this. All right, it's an even number, so I know it is divisible by 2. If I take 104 and divide by 2, I get 52. All right, so 52. I'm going to circle this because it's a prime number. All right, then I can break 52 down. I know 52 is prime, so even, so I can divide that by 2 as well. And I get 2 and 26. 26 is even, divided by 2, and I get 2 and 13. 13 is also a prime number. All right, so if you remember doing this, we did our little radical sign. You grouped together all of the like numbers. So I have a 2, a 2, a 2, and a 13. And we can pull out pairs of numbers. So you can pull out a pair of 2s, you get 2, and then you're left with a 2 and a 13. Multiply those guys underneath the radical, and I get 2 root 26. So just to double check our work, we know that the square root of 104 is the same thing as 2 square roots of 26. It's the exact same answer, we just simplified it. All right, so we're going back here. Hopefully I have enough space. Going back here, taking this answer here at the bottom, and I'm now writing it as x equals negative 12 plus or minus 2 root 26 all over 2. All right, I just replaced the square root of 104 with what I just simplified it down to. All right, last step for this exact solutions is I'm looking at this number, and this number, and I'm saying, can I reduce those three numbers? The answer is yes, you can. You can divide all three of these numbers by 2. All right, so final answer, if you're giving me the exact solutions, negative 12 divided by 2 is a negative 6, plus or minus. 2 divided by 2 is 1, so you don't need to write the 1, but I'm going to just to show you. And then 2 divided by 2 is also 1. Once again, you don't need to write the 1. So technically, your final answer is this right here. X equals a negative 6 plus or minus the square root of 26. You don't need that denominator of a 1. That is my exact solution. If you wanted to give an approximate solution, which makes a little bit more sense for graphical reasons, I can take negative 6 plus the square root of 26. All right, so one of my approximate solutions, because I'm going to round this, is going to be negative 0.9. All right, so let me write that down. So I'm now giving the approximate solutions. One of them is negative 0.9. The other one, if I take negative 6 and minus the square root of 26, sorry, let me show you. Negative 6 minus square root of 26, I get negative 11.1. Negative 11.1. All right, those are my approximate solutions. All right, guys, I'm going to post this video. This is assignment number 1 on PM Students. This is due to me no later than tomorrow night at 11:59.